in our vSphere topology so far, we have 3 standard vSwitches. One on ESXi1, one on ESXi2, and another on ESXi3. They all have the name of vSwitch 0. They all have one uplink using vmnic 0 that was done for us during the initial installation of the ESXi hosts. And each of the ESXi hosts has a single VM kernel adapter that's associated with a VM kernel port on that virtual switch that gives them access through the uplink on that virtual switch to the management network. So leveraging what we learned together in our previous nugget on the vSwitch concepts, let's go ahead and create a brand new vSwitch on ESXi2. So we already have vSwitch 0 that came by default. Let's go ahead and add a new vSwitch called vSwitch 1. Also, for that new vSwitch here on ESXi2, let's also go ahead and associate a physical network card that we can use as an uplink to connect to the external world outside of that ESXi host. And to do that, let's go ahead and use vmnic 5. So currently we have vmnic 0 that's being used as an uplink that's giving us our access via our VM kernel ports to get to the management network. And for this new vSwitch, we'll go ahead and use vmnic 5 as the physical interface that we're going to use to go ahead and connect to the external world. And when I say external world, I mean external outside of the logic and guts, if you will, of the ESXi host. And last but not least, let's also create a new VM port group on that new virtual switch. And let's name the VM port group new-VM_network. If our virtual machine, the Linux virtual machine, is connected and associated to the VM port group called new VM network, which is associated with switch 1, and switch 1 has the uplink of vmnic 5 to get to the outside world, that's the path the traffic would take from that VM to get to external resources. So for example, if this VM pinged, for example, 8888, a Google DNS server, the destination, because it's not local, would cause the VM to send that packet to its default gateway. And in this example, we're going to use this machine here, the Windows 2016 server, to also act as a router and network address translation device, supporting this VM network, the gray network right here. So if this VM has the default gateway of .100 and tries to send a packet out to 8888, the traffic would be forwarded from the VM through the ESXi host down through the uplink using vmnic 5. It would cross the network, go to the default gateway's IP address of .100, which would be 10.3.3.100, at which time, if the routing is working on this device, this server acting as a router could then forward it in the direction it needs to go to get to its final destination. And the next hop would be some other router that leads towards the destination of 8888. So that, my friend, is our game plan. Create a brand new switch, vSwitch 1, create a new VM port group, associate that VM with the new VM port group, and then test it to see whether or not it works. I've also got this Windows 2016 server acting as a DHCP server, also supporting 10.3.3. So if this client pops up on the 10.3.3 network and does a DHCP discover message, this Windows 2016 server can hand out an IP address along with the DNS server and default gateway that VM should go ahead and use. So without further ado, let's go to our Windows 2016 machine, connect over to vCenter server, and start our configuration regarding the virtual switch. Alright, so here we are on DCNUG. We'll click on the link right here, the shortcut for the vSphere web client. We'll supply our username of administrator at vSphere.local, along with our lab password, and click Login. I'm also going to bring this browser full screen by using the F11 key. And if for whatever reason, if you want to go full screen and it doesn't cooperate with the F11 key, you can always use this option right here by clicking on the Customize and Control Google Chrome setting, and then just click on the full screen icon right here. That'll also get you there. So let's go to the home page for the vSphere web client. Let's go ahead and hover on the home icon up here, and then from the drop down, click on Home. And let's go to hosts and clusters. So to get there, we can either click on this icon for host and clusters, or we can, in the navigator pane, click on host and clusters. Either way is great. So with the host and clusters tab selected, let's go ahead and just click on ESXi2, because that's where we're going to create this new standard switch. So there's a couple of different ways we can get to the configuration section regarding ESXi2. One is we could right click on ESXi2, and then from the drop down, click on settings. So let's go ahead and do that. We'll click on settings. And all that did was it brought us over to the configure tab for ESXi-2. So whether you right click and go to settings or just go to configure, it's going to take you to the same area. And then in this panel right here regarding ESXi2, we're going to go ahead and click on virtual switches under the networking section for ESXi2. So we'll click on virtual switches, and by default we have one virtual switch. It's vSwitch 0. If we click on that to select it, it'll then show us a visual representation of that switch down below. So here's our VM NIC, which is VM NIC 0. That's the uplink that's going out to the rest of the external networks. Here's our VM port group called VM network. That's just a label. And here's our VM kernel port. And the VM kernel port has the network label of management network. And if we wanted to edit those, we could go ahead and select them, click on edit, and we could rename those labels as well. So our goal is to create a brand new switch, associate a new uplink with that using VM NIC 5, and create a new port group associated with that switch. So to do that, to create new networking objects, we're going to click right here for Add Host Networking. And then when we click on Add Host Networking, and then regarding creation, we have three choices, three radio buttons. One, we could create a new VM network adapter. That's if we wanted to add a new, for example, logical layer 3 address, which would then be associated with that VM kernel adapter, and then subsequently associated with the VM kernel port on the switch. And although we're going to do that later in a different nugget, we're not going to do that now. What we want to do is create a new switch with a new uplink. Our second option here, physical network adapter, allows us to associate a network adapter, aka a VM NIC, a physical port, with a virtual switch. And that is what we want to do right now. And actually, we have another choice that would also work, and that is we could have selected the radio button for create a new virtual machine port group for a standard switch. And regardless of which of these two objects we select right now, on the next screen, in fact, let's click on Next to continue. On this next screen, it says, where do you want to apply this? Do you want to apply it to an existing switch? Or do you want to go ahead and create a new switch and apply that? So our objective is to create a new switch. So by selecting new switch here, we have two things in the queue. Number one, we specify that we want a physical adapter, a VM NIC, associated with the switch. And secondly, we just told it we want to create a new switch. So with new standard switch selected, we'll click on Next. Now, regarding this brand new switch that we are creating, it's now asking us about the uplinks, the VM NICs that we want to associate with this new switch. Currently, there are no assigned adapters of any type associated with this switch. So to add one of our existing physical interfaces on the ESXi host and associate it with this switch, we'd simply click on the plus symbol right here to add adapters. So right here it's showing us the available adapters, which are VM NICs 1, 2, 3, 4, and 5. VM NIC 0 is not shown here because VM NIC 0 is already associated and tied up, if you will, with vSwitch 0, the first virtual switch that's already in place. So based on our plan, we're going to go ahead and choose VM NIC 5 as an uplink to associate with this new virtual switch. So to do that, we'll go ahead and select VM NIC 5. If we had multiple VM NICs we wanted to use, we could just, like for example, hold the Shift key down and select a few, and that would bring them in. Or we could click one, hold down the Control key, select another, using traditional Windows methods for multiple selections. But for now, we just want one VM NIC, which is VM NIC 5. So with that selected, we'll go ahead and click OK. And as this implies, we could have multiple adapters with NIC teaming that could be used to support this new virtual switch. So for the moment, we're going to use one uplink for this one switch. So we'll simply click on Next to continue. Here's a summary of what it's going to do. It's creating a brand new switch called vSwitch 1 with the assigned physical network adapter of VM NIC 5. So we'll just click on Finish to go ahead and allow it to create the new switch with that new uplink. And here it is in the list. So vSwitch 0 is still highlighted and selected. If we click on vSwitch 1, it will show us the representation of that down below. So regarding vSwitch 1, we have one uplink using VM NIC 5 going out to the external network. And we have no VM kernel ports, and we have no VM port groups at all associated here with this virtual switch. Our next step would be to click on this Add Networking icon again and specify that we want to create a brand new VM port group and associate it with this vSwitch 1. So we'll click on the Add Host Networking icon once again. And this time we'll specify that we want to create a VM machine port group for a standard switch. And with that third radio button selected, we'll click on Next. And now, because we have the vSwitch already created, vSwitch 1, we don't have to create a new switch. We're simply going to add this VM port group to switch 1. If we had multiple switches, we could click on Browse here. It would give us a list of all our switches. We could select the one we want to go ahead and apply it to, and then click on OK. And then click on Next. Now, it's asking us about the network label for this brand new VM port group. And based on our plan, do you remember what we planned on naming this VM port group? And if memory serves me, you know what? My memory is not serving me correctly. Let me go to my notes. So we decided that we were going to call this VM port group, we're going to call it new -VM underscore network. Now, regarding this VM port group, if we wanted this VM port group to be a member of VLAN, for example, 20, we just put in the 20 there for VLAN 20. And then that traffic would be logically tagged as 20. And as it goes to the uplink, if the uplink is also using 802.1q tagging, it would propagate that tag as that frame goes out to the external switch. However, in this case, we are not using tagging of any type, so I'll leave the VLAN ID as 0, meaning please don't add any tags, and we'll click on Next. Here's our summary, and then we'll click on Finish. So great, we're almost there. We have vSwitch 1. vSwitch 1 has one physical uplink using VMNIC 5. It's got a VM port group called new-VM underscore network, and the challenge is we have no virtual machines currently associated with that port group. But have no fear, we're going to fix that right now. Over here on the left, under ESXi2, we see Linux-1. So we'll click on Linux-1, and if we want to configure the parameters for this virtual machine, we could right-click on the virtual machine. Notice here at the top, it's indicating that this drop-down is for that virtual machine called Linux-1. And from this drop-down, we are going to select the option named Edit Settings. So we'll click on Edit Settings for Linux-1. And then for the network adapter, currently, the network adapter is associated with the VM port group called VM Network. If we wanted to change that VM port group, we could use the drop-down. It'll show us all of the VM port groups that are available here on ESXi2. So we'd simply select new-VM underscore network. This yellow here indicates we have a change, and then we simply click on OK to apply that change. So we'll go ahead and click on OK. And now we can see right here under the VM hardware for Linux 1. And what we're looking at also is on the summary tab for Linux 1. It's now showing that the network adapter is connected to a VM port group, or it will be when we power this VM on, called new-VM underscore network. And at the moment, it says disconnected because the VM is not powered on. Also over here in related objects, it's also reflecting that the network that we're connected to is new-VM underscore network, which is the name, the network label for that VM port group. So before we power on that virtual machine, there is quite a bit that could go wrong. And let's go ahead and just set up some preparations in case we have to troubleshoot. So I'm going to hit F11 to take this out of full screen. Let me minimize the vSphere web client just for a moment. And here on DCNUG, this is our Windows 2016 server that's doing everything. DNS, DHCP, routing. Let's go ahead and launch Wireshark. There's an icon for it right here in the taskbar. And let's just capture the traffic just to make sure that it's seeing the requests and so forth regarding DHCP and regarding the traffic that is going to be sent from our Linux VM. So I'm going to go ahead and say skip this version. Regarding an update to Wireshark, and what we want to capture traffic on is the VM network. So I've got a network interface called VM network. In fact, let's real quick verify that. We'll right click on the Windows icon, bottom left hand corner, click on network connections, and then here on VM network, if we right click on that, and from the drop down go to properties of the VM network, I just want to verify we have the right address. So 10.3.3.100, perfect. So it has an IP address, the interface is up, and if we also wanted to, we could also go and verify the DHCP server is up and running, which I believe it is. If not, we'll troubleshoot that here in a moment. So let's go ahead and double click on this VM network interface to go ahead and start the capture, and we'll let that run in the background. So going back to Chrome and the vSphere web client, let's go ahead with Linux 1 selected. Let's go ahead and power it on. So we can do that by right clicking, hovering over power, and then selecting power on. And that's one of the several ways of starting this VM. So we'll click on power on, and we can also open up a console to it just by clicking here in the little preview of the screen for that VM. So we'll click on that. It opens up a new tab, and that virtual machine is off to the races. All right, so one of the benefits of VMware tools is having all the right video drivers and mouse drivers and everything else to allow the guest operating system to have a very good experience as a guest operating system living on a VM. So let's verify the IP address here on this device. There's several ways of doing it. One would be to simply click on the mouse in the upper left-hand corner of this VM and selecting Terminal Emulator from the list. So here in the terminal emulator, I'm going to click on the plus symbol to maximize that. And let's go ahead and type in ping space, and let's go to www.google.com. That's going to verify several things. Number one, it's going to verify that DNS is working. It'll also verify that we have connectivity to the live internet, which means everything's working. The DHCP is good, the routing's working, our new switch, the VM port group, and the uplink on that new switch are all working. So we'll go ahead and do a ping to www.google.com, press enter, and that is working. That's great. And also, just for grins, let's do an ifconfig and press enter. An ifconfig on a Linux box will give us IP address information. So there's the command, ifconfig, and here is the IP address that we have been assigned. So that looks like a complete home run. Honestly, I was expecting maybe at least one challenge with one of those components. But hey, I'll take the win. Let's go ahead and go back to Wireshark for a moment. And let's stop the capture. And we can do a display filter for some basic protocols. For example, if we click in this display filter area and type in boot P, that's how you spell DHCP, or the grandfather of DHCP, and we'll press enter, and that will show us any DHCP related traffic. So check this out. We had a DHCP request. That was the Linux virtual machine attempting to renew its old IP address. Because originally, it was on the 192.168.1 network, and so it was trying to renew that address. It got a nasty gram back saying, nah, no, not going to happen. And then it proceeded to do a discover and get an offer from the server, and then request that IP address and an acknowledgement back from the server, the DHCP server, back to that Linux box. Now, when you do this lab, let's say it's 6 months from now, you may or may not have these first two packets with the renewal request and the negative acknowledgement based on how much time has gone by and whether or not the client still thinks it should have that IP address. So the initial request and negative acknowledgement are variables time will tell. So we open up the payload of that original request and open option 50, which is the requested IP address. Yeah, he was trying to renew, at least in this trace, the IP address 192.168.1.104. And the DHCP server said, you're coming in on the 10.3.3 network. That's not going to happen. So then the client did a discover. Then there was an offer. If we click on the offered address, here is the offered address of 10.3.3.101. Is that the IP address that the client had? Let's go take a look, because it should be. Oh yeah, and sure enough. So there's the IP address 10.3.3.101 that was handed out and offered by the DHCP server. All right, so when you do this lab, if you'd like to do the protocol analysis, you're certainly welcome to. You don't have to. If everything works, you're good to go. So I'll go ahead and close Wireshark. I'm not going to save that capture. I'll go ahead and close the terminal emulator. And one of the great things that I love about having VMware tools up and running on a VM is that from the vCenter, we can actually implement graceful shutdowns of a VM, as opposed to just yanking the power or the equivalent of yanking the power, which could cause all kinds of problems with data that hadn't been committed to the disk from the VM's perspective. So I'm going to go ahead and move these windows around a little bit. Let me just bring this down a little bit and bring this one browser window out of the other one. And on the taskbar, I'm going to right click and say that I want to see the windows side by side. So here we have the VM, which is doing an amazing job, by the way, of resizing the graphic in the desktop. And I've got some error messages here. Let me go ahead and maximize the vSphere web client for a moment. And what this appears to look like is the fact that the vCenter server appliance, which is running as an appliance on ESXi1, it is having a problem communicating with ESXi2 and ESXi3. So if we clicked on ESXi2, and I love this error message, some elements could not be shown or their information could not be retrieved in time. Contact your administrator to fix the issue. Well, what if we are the administrator? So I think, let me think about this. I think that it's just the vCenter server appliance that's lost connectivity to ESXi2 and ESXi3, because check this out. If we go back to our virtual machine here, it is still running. And this is being powered by ESXi2. So for example, if we launched a browser by clicking on the little icon on the top left and clicking web browser on the virtual machine, and then we went out to a website, for example, like www.cbtnuggets.com, and pressed enter, because this is working, we know a couple things. Number one, we know that ESXi2 is still running, and that the new virtual switch that we just created is functional, because this VM is able to use that and go out to the internet, so that's all good. And what the problem is very likely our vCenter appliance. For whatever reason, it's having a problem communicating with ESXi2 and ESXi3, and it just started because a few moments ago, when we configured the vSwitch and everything else, that was us talking to vCenter and vCenter talking to ESXi2. So this is a fairly recent development. So let me go ahead and minimize this virtual machine. And let's go back to our vSphere web client. And I think what I want to do is, let's go ahead, because we know ESXi2 is running and it's fine, we'll do a refresh just to see if it comes back. Yeah, that's taking quite a while. It's not able to contact ESXi2 and ESXi3. So what I'm going to do is this. I'm going to go ahead and close the browser for the vSphere web client. I'm going to click on the VCA Management User Interface icon to take us directly to the vCenter Server appliance. Let's log in here as root, and for the password, we'll supply our lab password. Click Login, and check this out. So we know the vCenter Server appliance is running. So I'm not sure what type of network communications might be having a problem between ESXi2 and ESXi3 and this vCenter Server appliance. But what I think I'd like to try is a reboot in the lab environment, just to do a quick reboot of the vCenter Server appliance itself. So if there's some kind of an issue with its connectivity to ESXi2 or ESXi3, this will do a graceful shutdown and restart of this appliance. So we'll click on yes to do the reboot and cancel to log out. We'll close that browser as well. I'm going to give it a full like 5 minutes or so to go ahead and come back up. And then after 5 minutes, we'll roll the tape again, and we'll see if our problem is still existing, or if perhaps it was a transient issue with the networks that were connecting ESXi2 and ESXi3 over to the vCenter Server appliance. So it's been somewhere between 6 and 10 minutes since we rebooted the vCenter Server appliance. And I want to give it a chance to fully shut down gracefully and come back up and get all initialized. So now let's go ahead and click on the vSphere web client shortcut here on the desktop. So we'll double click that. And also I want to tell you that I changed nothing, zero, between now and when I left you 8 to 10 minutes ago. So let's go ahead and log in again as our user administrator at vsphere.local, and we'll put in our lab password. And with those in place, we'll click Login. So here in the vSphere web client, looks good. So I think we must have had some type of a hiccup, either with the network, the management network, that was connecting ESXi2 and ESXi3 over to the vCenter Server appliance. And one of the questions might be, at least I had it, was why didn't ESXi1 have a problem or a challenge? It seemed like the vCenter Server appliance could talk to it while it couldn't talk to the other two. And one of the answers to that might be in the virtual switch on ESXi1. Let's take a look at that just for a moment. So we'll select ESXi1, and then on the Configure tab, and then down under Networking, we'll click on Virtual Switches, and then we'll click on Virtual Switch 0. So, and again, remember this is ESXi1, and it's local vSwitch 0. So the VM kernel adapter, which is connecting to the switch via this VM kernel port right here, is 192.168.1.101. The vCenter Server appliance is a VM running on this ESXi host that's logically connected into this VM port group called VM Network. So if we expand the virtual machines, it shows us right here literally that we have the VMware vCenter Server as the virtual machine that's connected via this VM port group. So when this VM going into this VM port group and the ESXi host being represented by this VM kernel port, when they talk to each other, check it out, the traffic never has to leave this virtual switch. So it's very likely there was some kind of a problem or a hiccup out on the physical network that connected ESXi1 to ESXi2 to ESXi3, and it didn't affect the vCenter Server appliance communicating with ESXi1 because that traffic didn't have to go out to the physical network. At least that's a reasonable theory on why we had that connectivity issue that showed up a few minutes ago. Alright, so it's back in place, everything's great. Let's go ahead and click on Linux 1, the virtual machine, and let's open up a console to that. So we could right click and say open console here, or we could click here, or we could click here to open a console, or we could use this icon here to open a console to that virtual machine. And it's still happy. It's never been down. It's still at the website that we left it at originally. All right, so the extra troubleshooting exercise that we just did is not required. In fact, after I finish this nugget, what I'll do is I'll go back and I'll launch the lab from scratch. I'll walk through the whole thing just to verify whether or not that same problem happens again. I don't think it will. I think it was a random network problem in our virtual lab environment. And if it does turn out to be a consistent problem that happens every time, I will come back to this nugget and I will let you know. So if these are the last words you hear from me in this nugget, you know you're good to go. So it's now your opportunity, my friend, to go ahead and do what we did in this nugget, which includes creating a new virtual switch on ESXi2, associating it with an uplink using vmnic5, and creating a new VM port group called new-vm_network, and then associating our Linux virtual machine with that new VM port group, and then boot it up and verify that it can get out to the internet. So have some fun with the lab, and I'll see you, my friend, in our very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.